Hello and welcome to part 4 of the second of the 3 weekly lessons about Oracle Jet. So far during this week we have explored components that deal with data visualization and with data collections. In this part you're going to learn different ways in which you can access data in Jet applications and how to integrate data into Jet components to which you have been introduced. Throughout we'll be using JSON encoded data made available via REST services, which is the standard way in which data is made available in modern applications. What are REST services? REST stands for Representational State Transfer. In the REST architectural style, data and functionality are considered resources and are accessed using Uniform Resource Identifiers, URIs. The benefit of REST is its simplicity and the fact that it is a standard. For example, you can expose JSON encoded data via REST services from all the typical programming platforms, including Java EE, Spring Boot, and Node.js. Once you have exposed JSON data via REST services, you need a way for the client, in this case an Oracle Jet application, to access and integrate the data into Jet components. When connecting to REST interfaces from JavaScript clients, you must be aware of how JavaScript security is based around what is called sandboxing. By default, JavaScript does not allow you to interact with JavaScript resources outside of the domain that the application is currently running in. The current standard for allowing JavaScript client applications to talk to each other across different domains is called Cross-Origin Resource Sharing, or CORS for short. Enabling and configuring CORS is done completely by the REST endpoint server. If you try connecting to a REST endpoint and you get an error returned saying something like "No access control allow origin header is present on the requested resource," you will need to request that the REST service enable its core support. There is nothing that can be done from the client to work around this, as that would be a security hole if you could. jQuery is a widely used JavaScript library that is part of Oracle Jet. It includes a range of features to let you perform common tasks, including JSON document traversal and manipulation. Using jQuery to handle tasks relating to JSON is supported in Jet via helpful utility classes enabling the conversion of data from one format to another.
For example, here we see an OJ table as before. It has its data property set to a property named data source that is read-only, and it has 3 columns with fields mapped as name, population, and capital. Looking on the JavaScript side of this module, we notice immediately the usage of getJSON here from jQuery. If you're familiar with jQuery and you have used getJSON, be aware that you can integrate that directly into an Oracle Jet module, as you can see here. We start off by defining a KO observable array that we name data. At the end of the block of code, we pass that data into an OJ array table data source, which is an Oracle Jet utility class that converts that observable array into columns and rows for display inside a table. In the middle section here, we have a plain normal getJSON call from jQuery, calling out to a REST endpoint where countries are found, and inside of the JSON that is returned from the REST endpoint, we have a name, population, and capital that are pushed into the observable array, which in turn is converted into a table data source via Oracle Jet. What we get from this in our Oracle Jet module is a table with data retrieved from a REST endpoint.
There is a small problem with this code that people frequently make. Every time a change is made to the observable, the push in this case, an event is generated and all the elements bound to that observable are notified of the event. This can get really chatty if you have a large JSON result. Therefore, we need to change the code to use a temp array to push the results into, instead of pushing to the observable directly. The Jet common model is an alternative and more idiomatic Oracle Jet mechanism for working with data. It is inspired by a similar mechanism provided by the Backbone library. In particular, the Jet common model OJ model and OJ collection constructs allow applications to perform CRUD operations, create, read, update, delete, via REST services. In the context of CRUD functionality, using the Jet common model rather than jQuery is recommended.
The Jet Cookbook provides a number of comprehensive and complete sample scenarios for your reference, but the starting point in each case is to work with OJ model extend and OJ collection extend, which come from the backbone syntax, in a separate file which typically you would refer to as a factory. You might have a folder called factories where you would have a number of these collection-oriented JavaScript files which access your REST endpoint in a centralized manner, and via the OJ model extend have a way of referring to entities, and via OJ collection extend a way of referring to a collection of those entities. Once you have set that up, you would go to the module where you need to refer to that particular REST endpoint and load that JavaScript file into your view model. It is here the fourth reference, which means, as always, the fourth reference in the function callback must be that country factory. And then you refer to the method that provides the collection of entities, and then use the initialize method within your view model to load that collection of entities into the converter. So this is the Oracle Jet utility class collection table data source, and pass that into the data source which is referenced in your view. Finally call fetch, and the fetch is done and the data is made available to your view. This is a very simple starting point which only provides the read functionality of your CRUD application. For more details and comprehensive step-by-step guides for setting up CRUD functionality by means of the Oracle Jet common model, please refer to the cookbook.
What you will find in the Oracle Jet cookbook section on the common model is that the sample code doesn't make use of the factory approach introduced during this part of the course. The main reason for using the factory approach for the common model is that it can be much cleaner and better in terms of the code structuring, especially in large implementations of Oracle Jet. In the end, for larger applications, the factory approach makes for easier to maintain code. It is certainly not mandatory, but based on experience of several Jet developers in the field, making use of the factory approach can be very useful, especially when implementing changes in the future, since it makes it easier to navigate through your code.
You are not limited to JSON and REST when working with data in your Oracle Jet applications. However, these standards are most widely used, and if you are not using these standards already, you are recommended to explore these mechanisms. However, alternative approaches that work equally well with Jet applications include technologies such as XML and WebSocket for data transfer protocols. In this part of the second of the 3 weekly lessons about Oracle Jet, you have explored the mechanisms made available by Jet for working with data and for connecting data to Jet components. For your homework for this part, implement the OJ table from the cookbook into your own Jet application and try using both the jQuery getJSON call and the Jet common model approaches. Try both of them and see which one works better for your specific business requirements. As always, thank you for participating in the course on Oracle Jet. We hope you're having a good time and that you're learning a lot, and we'll see you in the next part.